Hi everyone, today I want to presentation about our group project. The title is Designing a Twelve Adjustable Power Supply Circuit using LM7805 and LM7905. Our group is the group A and our group member is Siti Aisha, Amiza, Nur Fatiha, and me, Bong Jawed. In the introduction, we want to design and build a dual-adjustable DC power supply circuit and convert the AC main voltage to regulated DC output. So we use the LM7805 and LM7905 IC to produce positive 5 volt and negative 5 volt. So this is provided a stable and reliable 12-voltage supply for electronic applications.
Theoretical explanation: the LM7805 produces a stable 5-volt output, while the LM7905 produces a stable negative 5-volt output. A potentiometer was connected between the common pin and ground to enable voltage adjustment. The potentiometer changes the reference voltage at the common pin, allowing output voltage control. Additional resistors were added to achieve an adjustable output range from 5 volt to 25 volt and negative 5 to negative 25 volt. This arrangement allows precise voltage tuning using the potentiometer. For the calculation, from here, we know that the value of the measurement V primary equal to 240 volt and the frequency is 50 Hz. For the Vin equal to 24 volt. For the filter, V-ripple is equal to 2.4 volt. For the load current is 1 ampere. So we can assume C, which is equal to IL over 2F V-ripple. And for the answer is, for the value is 4167 microfarad. For the calculation, we refer to R adjustable over R equal to V out over V reference minus 1. At LM7805, for the V reference equal to 5 volt, when VO equal to 5 volt, we need to find the value of ratio resistance. R adjustable over R minus 1, which is 35 over 5 minus 1 equal to 4. That's the ratio resistance value. And from there, we can assume potentiometer, which is R equal to 10 kilo ohm over 4. And for the our potentiometer value is 2.5 kilo ohm. At LM7905, V reference equal to negative 5 volt. When VO is equal to negative 5 and negative 25 volt, we can find the value with R adjustable over R minus 1, which is negative 25 over negative 5 minus 1, and the value is 4. There, we can assume the potentiometer R equal to 10 kilo ohm over 4, and the value is 2.5 kilo ohm.
This is a circuit simulation for dual adjustable DC output, a positive and negative DC output voltage with 5 voltage to 25 voltage and negative 5 voltage to negative 25 voltage at current 1 ampere using LM7805 and LM7905. The circuit was divided into transformer, rectifier, filter, regulator and protection stage. The center tap transformer provided positive and negative AC rails. A bridge rectifier using 1N4007 diode converted AC to DC. 4700 UF for capacitor we use to filter and reduce ripple. And LM7805 and LM7905 regulator with 10 kilo-ohm potentiometer enable voltage adjustment, and 2.7 kilo-ohm resistor and protection diode ensure the self-regulator operation. So this is the output voltage when potentiometer equal to 0, and output voltage when potentiometer 10 kilo-ohm for LM7805 and LM7905. For hardware, the result in oscilloscope when output voltage is 5 volt and when output voltage is negative 5 volt. This is simulation hardware result for output voltage positive 25 volt and negative 25 volt.
This is a table of comparison simulation and practical for our project. The first for LM7805, for the theoretical value is positive 5 volt. In the simulation, we get an output value of positive 5.005 volt, and the value obtained for the hardware circuit experiment is positive 5.89 volt. Therefore, the percentage value for theory and simulation is 0.10%. Next, the percentage value for theory and experiment is 17.80%. Next, LM7805 for the theoretical value is positive 25 volt. In the simulation, we get an output value of positive 25.195 volt, and the value obtained for the hardware circuit experiment is positive 25.60 volt. Therefore, the percentage value for theory and simulation is 0.78%. Next, the percentage value for theory and experiment is 2.40%. Second, for LM7905, for the theoretical value is negative 5 volt. In the simulation, we get an output value of negative 5.539 volt, and the value obtained for the hardware circuit experiment is negative 5.63 volt. Therefore, the percentage value for theory and simulation is 10.78%. Next, the percentage value for theory and experiment is 12.60%. Next, LM7905 for the theoretical value is negative 25 volt. In the simulation, we get an output value of negative 26.233 volt, and the value obtained for the hardware circuit experiment is negative 25.86 volt. Therefore, the percentage value for theory and simulation is 4.93%. Next, the percentage value for theory and experiment is 3.44%. In conclusion, this project successfully produced a dual adjustable DC power supply that can supply positive and negative voltage in the range of positive 5 volt to positive 25 volt and negative 5 volt to negative 25 volt with a maximum current of 1 ampere. The AC supply from the home socket is stepped down using a transformer, then converted to DC through a full wave rectifier circuit. The resulting DC voltage is filtered using a 4700 microfarad capacitor to reduce ripple. Next, the LM7805 and LM7905 voltage regulator IC are used to ensure that the output voltage is stable and can be adjusted using a potentiometer. Overall, this project shows how the concept of electrical engineering theory can be applied in producing a practical and useful power supply system. This is the link experiment for our project, and thank you.